Hello, today we are going to discuss about link state routing protocol. As far we have discussed about its link state routing protocol about the OSPF. In this we will learn about the another routing protocol, that is IS-IS, intermediate system. So in this we will learn about its type of packets and how IS-IS works and its type of routers, and then about the difference between OSPF and IS-IS. So let's first start with what is a intermediate system. So the IS-IS protocol is a type of IP routing protocol. So it is defined by the IGP, Interior Gateway Protocol, in which we know that IGP protocols involve the routing between a single autonomous system. So it is used to distribute IP routing information throughout a single autonomous system in an IP network. So in this protocol, router exchange topology or routing information within their nearest neighbors. So they share their routing topology or updates with their nearest neighbors, and it is used to calculate complete route through the autonomous system using Dijkstra algorithm. So it also used the Dijkstra algorithm to calculate the best route from the routing table. Hence, the complete route information is flooded in an autonomous system so that every router will know about the routing information about all the routes. So this enables an additional level of routing protection and a reduction in a routing protocol traffic. So it also add the security to the routing of the network. So the all routing information exchange can be authenticated so that only trusted routers can get the information for the autonomous system. So in this we will add that the best path is chosen by using the Dijkstra algorithm, and it only shares the update in the network, and it also use the security for the routing purposes. The next is the IS-IS protocol data units. So the IS-IS PDU units are of four types: the hello packets, LSP packets, CNSP packet, and PSNP packet. So let's discuss about these packets. The first is hello packets. This packet is used to establish and maintain the relations with the nearing neighbors. Then is LSP, that is link state PDU packet, as protocol data unit. So it advertise link state information or the routing information in the network. Next is CNSP, complete sequence number PDU. So these CSNP message is used to update or contain the updates about the complete list of LSPs known to the router. So it contains the complete list of LSP, that is the link state protocol, or the state of which tell about the state of every link, and it is given to every router in the routing table. Next is PNSP, that is the partial sequence number PDU. So it is used to acknowledge a routing update. So if when every router gets the routing update, it gives the acknowledge to a particular router about the received packet. So it is used to acknowledge routing updates on point-to-point links and to request missing information about a route after receiving a CSNP packet. The next is how IS-IS works. So each IS-IS router exchange information about its local state. Means whenever a IS-IS router gets started over a network, it start exchanging about the information of its links, that it is active link or it is a failed link. So that link is used to tell about the interface or the nearest neighbors and the cost of using each interface and to the other routers in the network. So it is sent by using the packet name as link state PDU, link state protocol data unit message. So each router build an identical database according to the received information. Then each router calculates its own routing table. After calculating the routing information from every routers, then each router in the network calculates its own routing table or a routes using a shortest path first algorithm, SPF algorithm, or Dijkstra algorithm. As shown in the diagram, this is a diagram of showing the IS-IS routing protocol, that it divides the one autonomous system into the areas, different area 1, area 2, and area 3. They have their own routers like L1 routers, L2 routers, and L1 L2 routers. So let's discuss about these routers. So the L1 routers, as shown in the diagram, it maintains a database of all router within the area. Means it only knows about the route that are in the route about the routers that are in a particular area. Then is L2 router. These L2 routers maintain a database of all the areas in the autonomous system. It know about the routes of the all the areas in the single autonomous system. Whereas a L1 L2 router maintain two separate databases, a one for the L1 databases that shares the intra areas routing. Means it the routing which is in a particular area, routing done in a particular area, whereas L2 database it shares the routing information about the inter area routing, that means within an autonomous system or between two or more areas. So as shown in the diagram, the L1 L2 routers are on the border of the areas and L1 and L2 routers are within the particular area. So next is the difference between OSPF and IS-IS routing protocol. So the first is the OSPF was designed according to, we have learned about the OSPF algorithm before. So OSPF algorithms was designed according to the TCP IP model, whereas IS-IS was designed according to the OSI model. So as OSPF used the concept of area boundary routers and the backbone area routers, whereas IS-IS uses the subdomains like level 1, level 2 and level 1. So IS-IS run over the layer 2, that is data link layer of an OSI model, whereas the OSPF run over the layer 3, that is network layer of an OSI model, TCP IP model. So this is all about the link state routing protocol. Thank you.